Welcome back to another exciting coding tutorial. I'm Bobby Davis, the founder of Foundry, and today we have an extra special coding challenge based on the 0 Hour mission in Destiny, the video game. If you don't know, 0 Hour is a mission in Destiny that you must complete to get the much sought after pulse rifle, Outbreak Prime. The heroic version of this mission is especially difficult, and you must complete it in order to upgrade your Outbreak Prime. The mission consists of clearing several rooms of shielded enemies, and there are multiple perilous jumping puzzles that test your platform abilities. You'll need to grab 2 teammates as you shoot your way through rooms filled with enemies, jumping around sheer cliff faces, and if you fall, guess what? You die. And as you jump, and jump, and jump, and jump, and die again, you face the real pressure of your teammates leaving you behind. But if you have picked your teammates well, they will wait on you and you'll arrive at the vault area. And you're confronted with one last puzzle. A grid of squares, but there's a catch. If you don't step on the correct square, you instantly die. So you try again, but to no avail, as there are no hints as to the pattern you must follow. But you persist, and your patience, or maybe it is your ability to Google that really pays off, and you find your way through this menacing maze, becoming the hero that you are meant to be. Running heroically, confidently, crossing this last puzzle with effortless grace. Just in time to bask in the glory of a selfie. You may ask yourself, what does Destiny have to do with a coding challenge? Well, we're going to take a look at those grid of squares and learn how to solve them in code. So take a journey with me as we solve the 0 Hour coding challenge. This will be a little bit of a lengthy tutorial, so I'm going to break it down for you. But first, what I want to do is show you what we're going to build. Let's check this out. So we're going to build a website that allows us to solve what I've called the 0 Hour coding challenge. And if you know, 0 Hour is a mission in Destiny like we saw in the promo. And I'm going to show you how we're going to relate that to the game in a second. But let's talk about the actual interview question that a person received while interviewing for Google. And it basically says this: you're given an R by C matrix, which is row by columns, consisting of booleans that represent a board. Each true boolean represents a wall, and each false boolean represents a tile that you can walk on. Given this matrix, a start coordinate and an end coordinate, return the minimum number of steps required to reach the end coordinate from the start. If there's no possible pass, then return null. You can move up, left, down, and right. You cannot move through walls, and you cannot wrap around the edges of the board. For example, given this board, and then we see the layout there, and you start with position 0, 0, and this is going to be on the bottom left, and at the end of 3, 0, which is the top left. The minimum number of steps required to reach the end is 7, since we would need to go through 1, 2, or column or row 1, column 2, because there is a wall everywhere else on the second row. Now, what I want you to note is this is the board that's represented by here. And the thing that you need to pick up on this right away is that this is what's called a multi-dimensional array. And that's kind of the clue, the way they put this in the question of what you're trying to solve. And a multi-dimensional array simply means that for every value in the position or the index, I have multiple values in it. So this would be, for example, row 0 right here, where I'm moving my cursor here, but it has 1, 2, 3, 4 values in it. As you can see here, I also have the true values represented with this hash patchwork or crosshatch, and that is going to be represented our walls, and everything else is we can walk on. So what this is saying to do is you need to tell me what squares from here, from 0, 0 to here. And so when we click solve, it will solve this maze for you and return the number of steps. Now, that is the default problem. Now, I took this one step further, and I made a second grid that's a little bit more complicated. And I added an extra obstacle here so that it would have to figure out multiple paths and go there. And you can see here, it marked this as a dead end because the wall is over here, but it solved the maze. Now we're also going to build the mazes from 0 hour. So if you've played Destiny, they come in 3 flavors, and Destiny has a void day, an art day, and a solar day. And depending on the day you're running this mission, the pattern will change. Now this one is a little bit different. I'm not going to read the whole explanation, but basically you don't know the start and you don't know the end. The only thing you know is where you start from and where you need to end as far as the row goes. You know the start row, but you don't know the column, and you know the end row. And that simply means we're going to start over here and we got to get across to the other side of the board. And so when it solves it, it basically walks through the maze. And I've got the actual mazes from the game in here, and each one of those is solved. So we're going to show you how to build this. I'm real excited about this and show you how to, but you're going to learn a lot of things in here. We're going to build this with Bootstrap, HTML, and CSS. So stay tuned for that. I'm going to give you some chapter markers in here in case you want to move around inside of the tutorial itself, because it'll be a little bit lengthy. We're also going to learn about multi-dimensional arrays, how to do that, and the trick to solving this type of maze, which is calculating the distance from one grid point to another. We're going to go through that, and we're going to go through the complete algorithm that you need to do to solve this, as well as some really cool, what I think are really cool CSS tricks to get this marking to work. So stay tuned, and let's jump into the code of 0 hour. So the first thing we need to do is we're going to use a tool called VS Code to construct this. And we're going to use HTML and CSS with Bootstrap to build out our template. So the first part of this, let's look into building out the template. Now, if you've watched some tutorials, and I've go in detail in some of the other tutorials around Bootstrap, but since we're going to spend a lot of time on the algorithm piece, I'm going to spend less time here on the Bootstrap itself. So I'm going to bring in some code, cut some code in, walk through it real quick so that we can move on to the really more interesting parts, which is the algorithms to solve these mazes inside of JavaScript. So what I've got here is I've got a standard Bootstrap template that I had built out with some of the plugins that I have in here inside of VS Code. You'll notice right away on my body tag here, I've got a class that is deflex flex column H100, and what this means is it's going to make this one giant column and take up the whole screen. And then on the load here, I want to go ahead and call my display grid, which is inside of my JavaScript, and I'm going to tell it which grid to load and the title of that grid. That means that so that you don't have to click a button when the page loads, that there's already a grid displayed. I'm also linking over to my style sheet, which we're going to use some CSS tricks today. And then I'm also linking to 2 separate JS files. I separated these so that we could go over the templating first and then code the algorithm for Maze Runner. So the templating is going to show you a really cool way to bring dynamic content into a page using template literals and building out little templates that way. So we're going to go over that. We're going to build the page and then go over the templates, and then we'll solve the algorithm. So that's a really short and sweet. So let's go through this real quick and show you what the bones of this is. So in general, we're going to have a div tag, and if you know anything about Bootstrap, every Bootstrap page has to have a div with a container on it. And so we're going to use container fluid, and container fluid means it's going to fill up the whole screen. But we're going to put it inside this flex column that we declared up here in the body tag. Okay? So that's the first thing we're going to do. And then a new element, if you've been following tutorials that I haven't covered before, is something called the nav. So we're going to make a nav element here, and I'm going to set a class on it, and then it's just going to be called, you probably guessed it, nav. Easy. I'm going to close that out, and then I'm going to, inside that nav, I'm going to put our HTML links. And what this allows us to do is give us a little navigation to go between the 2 pages we're going to build. So we're going to have an index page which solves the initial maze, and then the 0 hour page, which solves the Destiny theme challenges. They actually have 2 different algorithms, so we separate the page just so you can have clarity between it and make it easy to read and understand. Again, all this code will be up on our GitHub account, so that you can get the complete source code to this. No problems there. All right, so the next thing we're going to do is I'm going to create under this one more div, and I'm going to say class equals row. And inside this row, I'm going to put some margin in here, and that's called MT, stands for margin. And then I'm also going to set some left and right margins here. And so now I've got a row, and inside that row, I'm going to divide this row into 2 columns. The left column is going to hold our description. The right column will actually hold our grid of squares or our mazes. So how I'm going to do that is I'm going to divide this into, I'm going to make the left side 4, and then the right side I'm going to make 8. That's kind of the bones of what we're going to do. And then finally down here inside, this is kind of important. So inside of this container fluid, what I'm going to do is also use a new element called a footer. And so this footer has to be on the outside of the container. So our container will split up all available space horizontally 100. So I want a footer underneath that. Something like that. And I'm just going to copy this footer in here, and we'll go over it real quick. So what I've got here is I've got a footer. I give it the class footer. Again, the margin's auto, and I've got some padding. And then I text centered, which means it's going to center the content, and I got a span, and I just have a URL link in here. At the bottom of this, you could put URL to your portfolio. You could have a URL to your YouTube channel or your social medias, whatever you want to put in there. I just want to show you kind of how this works. And this will make it stay sticky down at the bottom. But the key to this is having this outside of this container. If you put it inside the container, it can act weird. So let's go through kind of what we want to do next. So inside this left column here, what I want to put is our descriptions in here. So description, or let's call it directions. And when you're making coding challenges, I want to be sort of clear here, is you always need to put the description of what you're trying to do, because someone may never heard of Fizz Buzz, or they may not have heard of 0 hours, so they need to know kind of what you're trying to solve here. And so like you always need to put that so that when someone comes to your website without you telling them, they can read it and go, oh, that's what that does. All right, it's just a simple UI point out for you put it on your portfolios. Always put a description of what the program is supposed to do. All right, so what I'm going to do here is I'm going to create some things called a card. And I like the card, so if you've looked at some of our other tutorials, especially one called Notary, we used a lot of cards in that one. And I'm not going to do anything different here. So I'm going to create a card, and we know that cards, if you know, really easy to remember, is cards have a header, cards have a body, and they also have a footer. You can use, you don't have to always use the footer or the header, but we're going to go ahead and do that. We're going to use a header and a card body here. So, and if you know that you can actually style any kind of element with the card header. So I'm going to use an H3 here. And I'm going to call this my card header. And what I did was I added a background color, and that's what this is a Bootstrap class, BG-primary. You can look the colors up on the documentation side of Bootstrap. This turns it blue, and then I turned the text white, and then I just said 0 hour coding challenge. So inside this card too, I also need another piece, which is the card body, as you guessed it. And this is the bones of this side of the HTML here. And so what I need to do in here is I'm going to actually cut and paste the rest of my code here. And so you don't have to watch me type that out, and I'm just going to go through it. So we have another div tag here, so they stack. This is my description. I put it in some simple paragraph tags. From here, I put an H6 element, made it bolder, and then I laid out my board also in another card, and I called that card and card-body, all in the same tag. And you can see here I'm not using header or footer, and that gives me that kind of styling that I want that separates it from everything else. Put some more p tags, and then also in this card, all inside this card. The one thing I want you to learn about this is that cards, card header and card bodies, you can put anything you want inside of a card body. As you can see here, I have a card inside of a card, and I've also got a class of rows and columns in here. And so this row underneath where I'm displaying the board, this is where my drop down button goes and my button to click to solve the maze. Now I'm using here Bootstrap drop down menus, and that's basically putting the class drop down in here, and then the overlaying button, and then underneath that I have button menu, and then I have button items, drop down items in here and on the buttons there. And so that allows me to have this clickable menu system in there to pick the grids. And in here I just kind of put what the grid items are, and then on click I call my JavaScript function display grid, and I'm passing it which grid do I want it to load when I click on that. And that's how that works. We'll go over these JavaScript functions here in a second. And then under here I have another button that's underneath this beside this drop down menu because it's inside the row. And then I just have a solve maze in there. And then I have a place to display my results. So that's kind of the left hand side of that. So let's collapse that, and now let's go to where we're going to do our maze template. And this is a lot simpler because most of the complexity is inside the JavaScript, because we're actually going to use templating for this part here. And what I did here is I've got an H1, and this is my grid 1 default. It does have a title of grid title, and then I'm using my own custom class here, or selector, and I call it color value, and I'm setting this dynamic based on some things. And I'm going to show you how this CSS trick works, because I use it quite a bit in the grids and also in the titles here, because some of the 0-hour ones I wanted them colored arc, void, and solar, and I wanted solar to be orange and arc to be blue and void to be purple. And so, but I use the same selector to get that done, and basically change its color based on its value. All right, and then I have a table in here, and so I'm using tables to display my actual grid squares, because that's what it is. It's rows and columns. And then I'm going to use a templating function to write here to write my rows and columns. So that is the HTML. So why don't we just move on next to the templating JavaScript, and let's do that next. Okay, so before we break into the JavaScript, let's just look real quick about what our progress is so far. So I'm going to bring up the browser here, and let's just see how we did on our HTML creation here. So you can see here it's bringing up our browser, and we have a couple links here, and I've got my HTML that I put in here. This is these drop down menu items that I put in there with the buttons, and right now they don't do anything, which is okay. We're going to do that here in just a second, and we've got our title in here, and we've got our solve button. So we've got our problem description, and our UI is looking pretty good. So now the only thing we left to do now is dynamically insert these grids in here. So let's do that with JavaScript, okay? So what we're going to do is we need to, we've got our table here, and so what I'm going to do is I'm going to insert rows and columns inside this table, and I'm going to use JavaScript to do that. So I created a JavaScript file called template.js. And there's a couple things I need to set up first. And what I'm going to do is copy these in. And I'm going to set up the multi-dimensional arrays that hold the definitions of the grids. So I'm going to post these in here. And you can see this is grid 1, grid 2, grid 3, grid 4, and grid 5. So they just have, and they're declared as constants. Constants mean that this will not change, or that you cannot change the way this is declared. Okay. However, if you're using a multidimensional array declared inside of a constant, the underlying values can change. So that I did that so to kind of bring up a point here that it's when you're declaring a constant, it's saying that grid 1 cannot change, but the values underneath it, they can in fact change. So they aren't, it doesn't operate exactly like you think it would. And so I had to code around this problem when I used a multidimensional array declared as a constant. Okay. So, so the next thing I need to do is I'm going to set up a sort of like a Boolean variable. And this variable is going to be able to be seen by both of my scripts. And it's going to hold the current grid, the current selected grid. And this is important so that I can know which grid they selected, so I know which one to write, and then also know how to solve the maze, because I use that selected grid to look inside these multidimensional arrays to figure out whether they're true or false, whether it's a wall or not. Okay? So I'm going to call that cgrid. And cgrid's going to just be currently right now just an empty array. Okay? And now what I'm going to do is write my function displayGrid. Now displayGrid is what's being called from the front end on our onload event, and also in all of our clicked events for the buttons in those drop-down menus. I'll show you that in a second. And it takes a grid and a grid title as parameters to it. And this function will render out rows and columns for displaying a grid. And that's the purpose of this function. Okay, and so I need to set up a couple of variables. So I've got an overall results HTML. And that's just going to be a string that I'm going to write to the browser, to the DOM. All right, and I also want to say my cgrid, which is my kind of like my global variable here, is equal to this grid being passed in. And I want to go ahead and set my title. So I'm going to say document.getElementById. by ID. And if you remember from our HTML, we have a thing called grid title. And grid title dot inner HTML equals the title being passed in. Okay, so that means that depending on which grid they select, I can change the title over the top of the grid so we know which one's being selected. Okay, so the next thing that I need to do is go ahead and set the color of these grids. So what I want to do is use a little bit of a CSS styling here, and I want to color them based on what the value of the grid title is. So check this out. So I'm going to write a little if statement here. If title dot includes, all right, and so that means that if the string passed in includes the some words here, and I'm going to go ahead and set up all of them right now, even though we haven't got to the second page yet. I'm just going to do this right now. It kind of follows the same pattern every time. Okay, so if I see one that's called void, I'm going to go ahead and get the element by ID, and I'm going to look for something called grid title. That's for the element, and then I'm going to do something called set attribute. And set attribute, and I'm going to look for a certain attribute, and I'm going to call this color value. And that's an attribute I put inside my HTML. And then I'm going to say, give it this value, void. Okay? Now let's go over real quickly what this is doing, and let me show you the CSS that's doing this. So if I look over at the CSS, I'm looking at color values right here, and if it's got the value default in it, use this color. If the color value has void, use purple. If the color value has arc, use light sky blue. And if the color value has solar, I created my own little orange here with an RGB value. Okay, so that means that if you go back and look at our HTML here, and we look at this grid title, it found this grid title right here. And then I made my own selector called color value, okay? And you can see here it has the value called default. So default, if you look at the top, is cornflower blue, just a light blue, okay? And so what I want to do is I want to set the value in here, and then it'll in turn change the color. Okay, hope that makes sense. So let's go through here and set all of these up, okay? So I'm going to write another else if, and it's going to be checking for arc, solar, and then the default, okay? So if else if, and so title dot includes the words, and we'll do the same thing here, and we'll go arc. So else if title includes arc, do some stuff, and I'm going to copy this line of code here, because all we want to do is do the same thing but give it the arc value, okay? And then I'm going to cut and paste this line of code so we don't have to watch me type all day, and I'm going to change this one to solar. So if the title includes solar, I'm going to set the color value to solar. And finally, else. And if it's anything else, I'm just going to default it to like a blue, the default value. So this will handle in case someone changed my JavaScript and passed it something that I didn't plan for. It will have the fallback mechanism of color value default. String. And so all that does is handle the coloring of our titles. So let's look at this, make sure that it's all working right here. Void, arc, solar, void, arc, solar, and default. Okay. So now let's get into like how we can display these. And so we're going to do this with a loop. Now I said this a little bit in the beginning, is that I'm actually going to invert the grid. So if you look up here, and we're going to use grid 1, the grids, this is row position 0, but I want this to be displayed at the bottom of the screen because it's more apparent to the user. That's more user intuitive. So what I'm going to do is I'm going to loop through those multidimensional arrays, but I'm going to loop through them in the reverse, and this is how you would do that. So I'm going to call something called iRow, and that's going to be equal to my current grid, which is cgrid, and length -1. So I'm going to start at the last row, okay, the bottom of that thing, -1. You remember that it starts with 0, so if it has 4 rows, the last row would be 3, okay? And then I'm going to go to the row greater than equal to 0. Semicolon. And then I want to do that until, or every time I do it, I want to say row -1. So all that's going to do is loop in reverse this way. So if you haven't seen a reverse loop, that's how you do a decrementing for loop. All right, so now the thing that I want to do is I need to set up some variables that are going to be contained inside of this loop. So I'm going to use a let statement here so that it's to this block, okay? And so I need a row value. I'm going to start out as empty string. And then I need a block value, and I'll explain these all in just a second. And I'm going to need a column value. And then I'm going to need a name. What I'm going to use this name for is to make sure that each of my columns in my HTML that I'm going to create actually has a unique name so that I can use those as we go through. Okay, so I've got that set up, and now as I'm looping through each row, I also want to loop through each column internally. And so now we're going to start the columns here from 0 to the end of the columns, okay? And so we don't know how long they're going to be. So I'm going to start this loop at 0, and this loops through the column. So if you look over here in our grid 1 here, these individual values here as I select them would be the columns, and this whole thing here in the bottom would be the row, and this has 4 columns, okay? So we need to loop through the rows as we go down through here, and then loop through each column for each individual row. Okay, so what I'm going to do here is create another loop. So I'm going to start at 0, and I'm going to say column less than, and what I'm going to get here is I'm going to say I want the C grid. I'll look at the C grid, the current row that I'm on, which is this variable in this outer loop here. So this is C grid row whatever I'm on. So in the first case it will be the last row, and I want to get the length. So I only want to go to the length of this particular row, okay, as long as it's less than that. And every time that I loop through, I want to go plus plus, okay? So long as it's less than the row of the length, okay? So that means, just to real quickly go over that real quick here, go up to the top one here. What it's going to do is when it's looping through the first one, okay, in our case, it is the bottom row that it's going to go first. It's going to say the length of this row is 1, 2, 3, 4. As long as it's less than 4, it's going to loop over, okay? So hopefully that makes sense. If it doesn't, I would be glad to work with you in the comments. Leave me a question and we'll go through it. You also can grab this code off of our public GitHub at Coder Foundry. All right, just look up Coder Foundry on GitHub and you'll find it. Okay, so the first thing that we need to do is set the block value, okay? So what we're doing is this block value is going to be in our HTML, okay? And so I wanted to know the value of the block. And so the value of the block would be whether it's a wall or whether it is something you can walk on or whether it has been walked on, and whether it's a dead end. So I have 4 scenarios there. I'm going to go over this real quick, but we'll go through how that's going to be worked when we start solving the maze. But this is just so that we can get it displayed, okay? Now, as I mentioned, so we're going to set these values here. So I'm going to say C grid, and I'm going to take the current row, and then the current column, okay? And that's going to be my block value. So what I'm doing here is I'm getting the current block value out of these grids. Okay, you can see here, these all have true or falses. I'm getting out the value, the current value in the grid, okay? Now, as I mentioned before, what I ran into was that as I was clicking around through the grids and solving them, what I would notice is as I solved them, that my code would be changing the values inside of these grids, okay? I thought I declared them as constants, and then I realized that, hey, you know, just because it's declared as a constant doesn't mean these values change internally. And so I'll show you that as when we write the maze runner JavaScript that it's going to do it. Now, the reason I'm doing that is because I need to mark whether the path has been walked on or not. And we'll get into that in just a little bit in a second, but I just wanted you to understand what I'm trying to do here. So I get the current value of the current block value that's in the array right now. Typically when you start out, that'd be T and F, but I also created FP, which stands for path, and FX, which stands for dead end. So FP would mean that I've walked on this already, and FX means I've walked on it and returned from it, but it's a dead end, okay? And a lot of this will make sense when we get into algorithm solving the maze, but I need to go ahead and clean up these grids and reset them to their current state. So it's going to be real easily done with a switch statement. So C grid, and I want to get the I row, the current row, and then I want to grab the current column, okay? And I want to check two lowercase. I just want to make sure that I'm checking the right thing in case something else changed it. It's a good practice when you're comparing strings to another string to make sure that they're in lowercase or uppercase or something like that, so you don't have these case mismatch problems. Okay, so case T. So if I see a T coming back from the grid, my block value is going to equal wall. And this is going to make sense in just a second. All right, and I want to break out of here. If I see a case of F, my block value will equal path. All right, I want to break here. Save it and I'm going to reformat it. And then I've got a couple of edge cases here, and this is if I've already walked on the path. I want to reset it to its default value. So if I see FP, which means I've tried to walk there or I have walked there, I want to go ahead and reset its block value. Okay, so block val is going to equal to path. Okay, and then I'm going to reset the grid value too. So like the current grid, the current I row, and the current column equals F. Okay? So I'm resetting it because I've tried to solve these more than once. Okay? And then I've got one more edge case, and I called it FX. Not the channel, but just means dead end. And I want to reset it to a block value. Its block value equal to path. And then I want to go ahead and change it C grid, I row, I column equal to F. Okay? And I want to break. So that's just kind of a housekeeping thing. If you stay with me and we get through the maze runner, all this will make sense. But I wanted to go ahead and do this while we're here creating it to display our grids. Okay, so that's our main kind of loop there. And so now what I need to do is grab inside this loop here, okay, and outside this switch case, I want to go ahead and get my column value, and I'm going to set it to C grid, I row, and I column. This will return true or false. Okay. Then the next thing I want to do is I want to create something called a name, and this is going to be the name I'm going to use in my HTML. Now here's where it gets kind of cool, I think, and I'm going to use something new that you may not know about. I'm going to use something called a literal template, excuse me. And how do you do that? Is it's being able to insert values inside of a string is what it's really good for. And how you do that is something a little bit interesting here. We're going to use the tick sign, and the tick sign is under your tilde sign, usually located on the top left of your keyboard. Now you have to be very careful that you're not using the single quote, okay? Single quote looks like this. The tick sign looks like this, okay? If you use a single quote around it, this isn't going to work, and make sure that's one common thing that people run into when they're using template literals or template rules. And so make sure you're using that tick sign. And then you follow this naming convention. You put the $sign, and whatever's in this bracket, you can pass it variables. I'm going to pass it the variable iRow, okay? And then I want to put a colon, and I'm going to create another variable that I want to pass in, and I'm going to pass it iColumn, okay? And what this allows me to do is I'm going to use the row and the column and name each cell in the rows and columns I'm getting ready to create with this unique name. So it'll start, if it's row 0, it'll be row 0, column 0, row 0, column 1, etc., etc. Okay? So then I'm creating some HTML here. Then I'm going to take my row value, and I'm going to say plus equals, and I'm going to make a function, and I'm going to call this render column. And render column is going to have a thing called column val. I'm going to pass it the block val, and I'm going to pass it the name. Okay? And so what I want to do here is I'm going to write this render column here in just a second. I want to get the rest of this out. And then I want to have my results HTML equals or plus equals render row. And I'm going to write another function here called render row, and I'm going to pass it the row val that I'm getting. And then finally, after all this work, I'm going to write it to the screen. And so I'm going to say document.getML_ID, and grid display is the one I'm looking for, which is that table that I created in my HTML. And definitely going to call enter HTML because I'm actually going to write HTML to the screen here, and that's going to be equal to results.html. Okay, so that is our base function. So now what I'm going to do is I'm going to go over here, and I'm going to write two brand new functions, because you notice that I have these render columns. So I'm going to say function, and now I'm going to write my render column function. And this is pretty short, so stay with me. Very simple. Okay, and again, we're going to use template literals here. So let's do, this is our template function. And if you watch what happens, we'll show you real quick how this works. And you can use this on lots of things. I think it's pretty neat. So I'm going to take my values, which is column value. I'm going to take my block value, and I'm going to take my name, and I'm going to pass that to this very simple statement, and I'm going to say return. Okay, and I'm going to use the tick mark, and that's really important. I can't explain to you, like, I've had people ask me, like, these don't work, and then you realize that they're using the single quotes and not the tick mark. Okay, so I'm going to create a TD. So this is each individual column. So for each row in grid 1, I'm going to have 4 of these, and I'm calling them in a loop. And so I need to set up the ID for this column. So remember, this is just HTML that we're creating here. And inside of that, I want to use a template literal, and I'm going to pass it the name. So the name of this column would be the row that it's in and the column position that it's in. So to be like 0:0 would be the first column. Okay, and then I've got my selector called block value, and this is the custom selector that I made. I'm going to show you the CSS here in a second why I did this. And I'm going to pass it another variable, and I'm going to call it block. I'm going to use the block value that we're passing into the function. Okay, I'm setting them a block value, and then this has a class that is going to be used. Okay, so I'm going to say class equals, and it's going to be called grid style. Okay, and then finally, after all of that, let's tab this over a little bit. I'm going to, inside the column, the actual value that's going to be in here. And I'm going to say column val. And now what's going to go on here is this HTML template here, we can now take these values that's being passed in and insert it into this string. Now normally you could do this with string concatenation with like a bunch of plus signs and all those kind of things, but this makes it a lot more readable and a lot easier to define these templates than trying to do concatenation with regular strings. The secret is you got to have the tip mark here for the template literals, and then you also got to use this naming convention, $ in the brackets, and push your variable content in between that. Okay. You can also put constants in here as well if you want to, but it's really useful when you're doing actual, you want to pass in dynamic content into it. Okay, so let's write one more function here, and this is going to be called render row. So every row is going to have one-to-many columns. We don't know how many that's going to be, so we're just going to pass in the row value. And you'll see how powerful this is right now, because all I'm going to do is I'm going to return, and I'm going to use the tip mark again, and tr, and I'm going to give this row an H100 for the height. All right, and now I'm just going to pass in $, bracket, and then I'm just going to pass in the row val here. Use percent sign. Let me get that right. Clean this up a little bit. So to review, let's review now that you've seen the whole code to render out these templates, okay? And hopefully this works. So review it and then run it, and hopefully it works, okay? So the first thing that we did was we created a loop, and this is going to be our row loops. And this loop right here is going to loop through a row in one of these multi-dimensional arrays, okay? So it's going to start here, 0, 1, 2, 3, 4, 5, okay? Now what I told you was we're actually going to loop these in reverse so that you can start at the bottom on the screen and the user has a better understanding of how this works. So it'll start from the bottom and loop up, okay? Now for each row, it's also going to loop through each column, and that's what this second iteration or this second for loop is doing. And what it's going to do is when it's on this row, it's going to loop through each one of these columns, this false, this T, this T, this T, this T, okay? And I'm asking you to stay with me to show you that I'm resetting the values in these because that grid does get changed as we're walking through and solving the maze, okay? So this resets it up to puts it at the default state of what it should be. And then I take those row column values, that's a bug. I take those row column values and I say cgrid at row and column and get the column value. So that'll be the T or F that's back there. Okay. If you notice here, I'm resetting them up, and that's why I check this at the end, because I don't want to pull back an FP or an FX. I just want to pull back either T or F. And then I take the row and the column and I'm going to use this in my template literals. And then I call render column. Okay, I pass it the column value, the block val, and the name. Okay, and in here I'm creating a TD, so it's going to be a row and a TD, and I give it a name, I give it a block val. Now let's look at this block val and see what this is. So if we look over on our CSS, I'm using the same trick I did for the colors over here. And you can see here that I have a block value. If it equals dead end, path, wall, or step, it's going to make these colors, okay? So in the beginning, we're only going to have wall or path, and that's dark gray. And then I use this right here, which is a SVG that makes this really cool crosshatch program. And so you can looking for CSS values for crosshatch or in all kinds of like patterns and CSS patterns. I just got this off the internet and copied it in. And so also you can see I have steps, it's going to be blue. If it's a path, it's going to be dark gray. If it's a dead end, it's going to be orange. And this block value CSS selector that I put inside my template is controlling all of that. Okay, we will modify these block values in our Maze Runner JS soon. Okay, so if we've did everything right, this should in fact work, and let's check it out to see if it does. Okay, so let's see if this is in fact going to work, and let's check it out here. And I'm going to go live here, and it should start up. And it didn't display. Nothing happened, so we must have a bug here. So this is one of my hot tips for today. I'm going to show you how actually we could debug this and solve the issue, because I actually did make a typo in there. And I want to show you how we could find that and how we could debug this JavaScript file. So I'm going to put this to the side just for a second, okay? We're actually going to close this down. Now, what I'm using here to display is a thing called Live Server, okay? And also I have built-in debugging support here inside of VS Code, okay? So I'm going to click on the debugger. And I want to show you a couple of things and how it's kind of put together. There's this file called launch.json, and to set up live server JavaScript debugging, you create a configuration, and by default this is what you need. You need the name, doesn't really matter, you can call it whatever you want. This is what confuses people. You have to have this correct URL, and so you'll notice when you launch with live server, this is the URL it's using for me. You may have a different URL. This port could change a lot depending on your configuration. Typically, when you run live server, it's going to run 127.0.0.1 as your IP address. But if something else is in there, for you guys that know a lot about URLs, you can like mask this, you can do whatever. But by default, this should work. And then what we can do here is once you launch live server, which you can tell right here, the port's running, I can click on my debug menu. This is my editor or my files here. I click on debug, and here I'm going to hit this green arrow button or the play button to start debugging, and watch what happens. Okay, so nothing happened, but I'm going to pull this to the side. Look at this. It gave us an error that we can look at, okay? And so it says right here that I0W is not defined at display grid template.js line 69, and that's what it means. So let's go look at 69 in our file here. So I'm going to go over to my template.js, and I've got line numbers here, and look, that meant to say row, it's not really IOW, it's iRow. Okay, now I can save that. Okay, and now look, our grids are up. So that's kind of how you would debug JavaScript. I think that's very essential to learn how to debug JavaScript. And notice here, if we look real closely, it's loading in our other grids, and these are other style grids. And if even, I believe, if I go over here, I can even upload maybe some other ones. Okay, we haven't done those yet. Yeah, we haven't done the HTML one for that yet. So for now, we've got this working, and that's pretty cool. So that is, in fact, our how we display our grids inside of our HTML page here. So now let's move on to coding up the actual solve so we can make this button, this solve button, work. So we've covered debugging, and we'll use the debugger a lot in the next segment. All right, so before we jump into the code here in VS Code, I thought I would take just a few moments to give you an overview of our overall approach to the code. So I've got just to walk through this with you, so in your mind as you're watching the code, you can kind of know where we're going to go. So the first thing that we need to do is create a do loop instead of a for loop. And a do loop will loop until a condition is met. We're going to check for exit or cannot move anymore. So we'll loop until we reach the exit or it's unsolvable. Inside that loop, on each iteration, we're going to test for each direction, up, down, left, and right, to see if you can move there. Okay? And we're going to calculate the distance from the current cell, row and cell, to the exit for each possible move direction. So we test for up, down, left, and right. And if we can move to any of those directions, if it's not out of bounds or not a wall or anything like that, then we'll, from there, the possible moves will calculate the distance from that to the exit. Then next, we'll add each possible move to an array. And then we'll sort that array by the distance in ascending order so that the closest next moves are first. Okay. And then we mark the current column we're on as used, and then we add to the step count. And then finally, we set the current row, the one we're currently on, its row and column, to the closest next move row and column. So this is in our variables that we're tracking. We'll have a current row and a current column variable, and we'll set that equal to the closest move, possible move that we found. And that's going to be the first position in that array because it's sorted by ascending order, and that's really important. And finally, at the end of our loop, we'll test for an exit. Did the row and column that we found, is it equal to the exit row and column? Or are there no possible moves, meaning there was no values at all in our array? Then we can exit. If not, we loop and repeat these steps. So that's what we're going to do. So let's jump into VS Code here and see how we do that with JavaScript. So let's open up our template.js, and now let's take that back. Let's go into our maze runner.js, and I'm going to declare a couple of things up here. So I'm going to declare some constants, and I'm going to call this directions. Now what I'm doing here is setting up a classic, what we call an enum in other languages, and it allows us to have this kind of really self-describing code. So I'm going to use these so that the code's more readable. So I'm going to set these up here, and you'll see how we use them here in a second. So I'm going to make an array of values here, or an object, and it holds the value of lowercase up, and left holds the value of lowercase left, and down or right holds the right, and then we'll go down. And what this allows us to do is check by declaring a directions.up, we can check the value of that, and we don't have to check for a string value. We can check a constant, and that makes sure that we make less mistakes when we're checking values. And I'm going to create another one here. I'm just going to paste it in, and this one's going to be column values. And column values allows us to check for wall, open, path, or dead end. Internally, the value is T and F, and then what we did to solve this is we also added our own value of FP, which means that it was a free area or an open area, but we marked it as a path, and that means that we've already been to this square. This allows us to calculate. The other one's called FX, which is dead end, meaning that we've been here before and we don't want to go back, and so we mark it as a dead end. All right, so that's kind of what we're going to do there. We're going to use those throughout the code. So In the first example, we need to set up the start and exit. And exit. And so I'm going to create some variables here, and it's called start row. And it's going to equal to 0. And I'm going to say var start column, say call, and it's going to equal to 0. So we're going to start at position 0, 0. And then we're going to exit to 3, 0. So I'm going to say that our exit row equals 3, and our exit column equals 0. Okay. We'll use this exit row and exit column to test at the end of our loop like we did in our code overview, and the start will tell us where to start looking for the next possible move when we start up our loop. So that's what that's for. So let's get into it here. Let's write a function called solve maze. Takes no parameters. Let's go ahead and set up our scope here. And I've got a lot of variables that I need to set up in the beginning. So I'm going to cut and paste those in, and then I'm going to walk you through like what all these do. So in the beginning here, if you remember what we did, we set up the C grid when we were doing the template. This is going to be passed around as a global variable between the JS files. And cgrid will give us the current grid the user selected, either the default one on load or if they selected it from one of the drop downs. These two cur row and cur column we're going to use to say what row and column we're currently on. We're going to default that to the start, which is 0, 0. The previous row and the previous column is the last row and column that we were on. Okay. We're going to use that to see if it's been traveled there before and do we need to mark it as a dead end. The step count counts the total number of counts that we've taken to solve it. And then we've got a couple of booleans here, which is exit reached and no exit. Exit reached means that we have reached the exit. No exit means there are no moves and we need to go ahead and get out of our loop. This is so we don't have an endless loop condition inside of our do loop. We're also going to calculate the minimum distance, and we're going to show you how to do that. And this is the variable will hold that value. And then we're also going to have our next direction. And then we're going to have a move up, move left, move right, and move down. And we're going to return an object from a move function. And I think that if you stick around for that, that is a really kind of cool technique that you can use. Sometimes when you write a function, it needs to return more than one value. The way you do that is return an object from that function and then check the properties on that object and when it returns. And we'll show you how to do that in a second if you stick with us. So I think that is a cool technique you may pick up today. All right, so that's the setup of our variables. And so let's go ahead and do one more thing. I'm going to go ahead and mark the start of the grid as part of the path, meaning that this will be marked blue if you remember when we showed this. The reason we do this is so we're going to go ahead and we know that we're going to step on that. That's where we're starting. And we also want to mark it as you can't go back to the start. One of the things that we want to know is that you can't start over. You got to keep moving forward, okay? Just like in real life. You just got to keep moving forward. All right, so I'm going to mark that with our start row value that we set up. And so our grid is, remember, set was equal to the current grid. And then, so all I have to do here is hit it with our multi-dimensional access here with start column, start grid, start column, and we're going to set it equal to column values dot path. All right, so this is the first time we're going to use one of those enums that we set up. So let's look at it. That means that we're going to set the value in the array to FP. It was F, but now it's going to be FP, okay? So that way we can test the values in here. And that's when, if you remember, in our template function, these grids are set up in here, but they're marked as constants. But because the constant is the value of the constant is an array, we can still change the values in here. So we're actually changing these underlying values in this array to figure out where we've been and where we need to go. Okay, so that's what that's doing. And see, you can see that's a whole lot better than setting it equal to some kind of string that we type over and over again. This gives us a really kind of typed value, and it's also very readable. And you can click on this and you can see here it's showing me the values in call values. So it's gives me some IntelliSense there as well. So it's a really cool thing to do if you're trying to check multiple values like that. Okay, so then what I can do is I'm going to do one more thing here. I need to actually mark the HTML. And so my element ID of the item I want to mark, and I'm going to use my template literal here, and I'm going to insert some values in here, and I know the names of it because I used a naming convention. And it's just start row, and then I'm going to put a column. I'm going to use another template literal, and I'm going to say start column. Now, since we used a naming convention when we set up our template, we know the names of each one of these columns that we're going to mark up. And so now that I have the element ID, I can simply do this, which is kind of cool. I can say get element ID, and I can pass it this element ID in there, and then I can set my attribute, because this is what's going to set my color. And if you remember, when we're setting the colors, or where we're doing the gray and the hash, now we can do is use the same technique, and we're going to say change the block value to step. Okay, and if we look over here at our CSS, our block value step is cornflower blue. Okay, so it's kind of cool. And so now the first element is marked blue, and the underlying value in the array is FP, and that's what those two lines do. All right, so let's solve this maze. Let's get to it. All right, so the first thing I'm going to do is I'm going to write a do loop, and then I'm going to go ahead and put in the condition for that do loop before we get going. Okay, and show you how that's going to work. Paste some code in here. So we're going to do it while our variable exit reached is equal to false. Remember, we're not setting it here. We're setting it equal to false. And no exit equals true, which means we're testing to see if the equality between these two statements is not an assignment. And that's what equal does. And so if the exit is false and the no exit is true, meaning we haven't got an exit yet, keep on looping. However, and if one of those is true, and if its exit reached equals true, then we're going to say give us a step count. Okay. If there is a no exit, we're not going to report a step count at all. Okay. In fact, what we could do here is we could say else, and we can copy this, and we could say cannot find an exit. And we'll change this from the ticks down to the regular strings. It's kind of cool. All right, so that should solve all of our problems there. And so let's get into writing the code inside of our do loop. So we've got our conditions set. I think it's always good to set your conditions first so you don't run into, when you're testing, some kind of endless loop option, especially using do loops. All right, I'm going to create some variables here, and this is called next step. And next step is an array. And we're going to put some values inside of this. We'll use it in a second. And I'm going to say my previous row, when I first start out, is equal to the current row. Okay, when I loop around, I want to go ahead and set up my previous row stuff, values. And I'm going to go ahead and let some previous column equal to the current row. or current column, excuse me, because that would mess it up. And now what we want to do is we want to test for our moves. Okay, and so what we're going to do is we're going to test to move up, and we're going to test to move down, move left, and move right, and we're going to use a move function to do that. Okay, so what I'm going to do is I'm going to write the call here, and then we'll create the function. Okay, so move up is going to return an object. Okay, so our move function is going to return an object. All right. So what I'm going to do is I'm going to call this move, and I'm going to pass it the current row. I'm going to pass it the current column, and I'm also going to pass it the grid, and I'm also going to pass it the direction that I'm checking for. And in the case here, I'm checking for up. And again, I use this this constant called directions. And so now this is kind of self-documenting here. I like that instead of just passing in a string in there. All right, and so so that's all I need to do, and this will return an object to it, and then we'll move on. So let me write the actual move function here. And so what we need to do, and this is kind of where a lot of our work happens. So let me test this out. Let me put a comment here. All right, see if we can move to the next square. And we're going to also calculate the distance to the exit. Okay, so as you remember, this thing takes current row, it takes a current column, it takes a grid, and it takes a direction. And I'm just going to call this direction because I'm passing one value to it. Okay, so what I need to do is set up a couple of variables inside of here. So I'm going to call this target row, and this is the one we want to get to, and we need to determine if it's possible to go there. Sometimes they're out of bounds of the array, sometimes they're a wall, and sometimes they're maybe a previous destination, something like that. So we're going to set the target column equal to the current column. Okay. And then we're going to set the target value because we need to get to see if it's an FP, a T, an F, an FP, or an FX. Target value, and we're going to set it up to empty string first. And then I need to see, can I move there? And that's a Boolean. We'll set it equal to false. And then finally, I'm going to set up my minimum distance. And I'm going to set that equal to -1. Okay, so these are our variables that we're going to use here. Let me change these bars. Let's just do it all the same. Okay, what did I do here? Oh yeah. Okay. So the one thing I want to do is I want to switch on the direction. So again, this is going to be our direction is going to be our constant that's being passed in. And look how self-describing this code is when you use these things. Up. Okay. And so I'm just testing for the up. And if I go up, I'm going to set my target row +1. So it's going to equal to the current row +1. Okay, if I go up, and this needs to be a colon, so that's my case value. And then what I can do is just break out of here. And then I need to do this for each possible direction, which is 4. So I can just say direction dot, and I'm going to do left. And in that case, if I go left, it's going to be target column equals current column minus 1. Kind of cool. Break out. And then case directions dot, let's go right. And if I'm going right, it's going to be column plus 1. So my target column equals current column plus 1. And then finally, I can say case directions down. Let me forget my break here. I only want to test once. And if I'm going down, it's going to be my target row equal to current row minus 1, because I'm taking 1 away and I'm going down. All right, and break there. So that sets up where I want to go. Kind of cool. And now I want to do a couple of checks here. First thing I want to do is check to see if it's out of bounds. Let's just check for out of bounds. And so what that will do is, if we're beyond the array, we don't want to try to move there. And also in the instructions, it said you can't wrap around the board. So what we need to do is set up a little bit of an if statement here, and I'm going to push this in here, and we'll walk through it. So I'm going to check to see if the target row is greater than the grid length minus 1. So the grid length would be 4 in the default case, and minus 1 would be if the row is greater than 3. Okay, so that means that because it starts at 0, the last row would be 3. Or, and that's what the double piped here for, target row less than 0. So if we took row from it and it's less than 0, like -1, or the target column is greater than the grid target row, which would be the current row they were in, and then look at that row inside of that to see if it's greater than the length there. Okay, so we don't want 4, we don't want it greater than, if we have a 4 columns in there, we don't want it to be greater than that. And then make sure that the target column is less also greater than 0. In this case, if it's less than 0. So if any of those things happen, we want to do a couple of things, and we just want to return out. Okay, and what we do here is we set, and this will return in our object, and we say can move false, minimum distance -1, the direction is the direction that we were in, and then column value is, we want to just say that it was a wall, but that one can't be, we can't move to it. So we had to put something in there, so we put the wall value. We're just saying that anything out of bounds should be declared as a wall, even though we can't move there. All right, so we would check that and get out. The next thing we would check for is get the value of the square we're trying to go to. And so target value equals, okay, and it's the grid and it's the target row, and you can guess it, we want to get the target column. We get the value out of that position in the array, and that gives us our target value. So now we know that we can If it doesn't get through this check and doesn't return here, we know that we can actually move to there, and it's not out of bounds, so we can go ahead and test to see if there's anything else. The reason we test for out of bounds first is that if we tried to call this and it was out of bounds, it would throw an error. So we want to make sure that there are no out of bound possibilities before we start looking in the values in arrays. All right. So we need another if statement here, and we've almost got this, but right here we're just going to test for all of our conditions. Okay. So first thing we need to do is test to see if the start row and the target row are equal, which means that we cannot move back to the start, we cannot go back. And that means if this case is met, then we would say can move is false, minimum distance is 1, the direction is the direction being passed in, and the column value that we have is wall. Okay, that just means that you cannot go back to the start, and we don't want that to happen. Okay. The next thing that we want to test for is if let me show you this, and we test for a wall or a dead end. Okay, so else if the target value equals column values wall, and if the target value equals a dead end. So that means that if it's a T or an FX, we return we cannot move here because we can't go through walls, and a dead end, we do not go back to dead ends. We keep moving forward, and so then we set the column value is the target value. Okay. All right, and so then finally what we're going to do here is we're going to test for a path condition, which means that, hey, this is a move. And we'll show you how this works in just a second here. So now we have else if the target value equals a path. That means we can move will be returned true, and then we calculate the minimum distance right here. Okay, we're going to show you how that works in a second. It's an equation, and then we set its value, and then we also want to go ahead and bounce out of here, and we want to set up a default return. Okay, and if for some reason that there isn't a condition that we didn't think about is not met, we're going to say you can't move there. Okay, and so if all else fails, just return a cannot move is equal to false. All right, so let's look at this minimum distance. I'm hoping here that you learned something, and I'm going to just copy this function in here. We're going to write a minimum distance function right here. Let's see, we'll make sure that we're outside of that. It's outside of our move function. So if you don't know anything about, if you don't remember your 9th or 10th grade math, you can calculate the difference, the distance between a grid on a square, and this is how you do it. Basically, you pass it in the target row and the target column, and you say the exit row minus the target row, and you take the absolute value of that, and you add the absolute value of the exit column minus the target column, and that'll give you the amount of steps would be from the current position to the exit. Very simple to do, but if you want to look at how you figure that out, you can, go to some math sites and see how do you calculate the distance between 2 points on a grid. And this is what we're doing here, and I'm just going to give you this function to show you kind of how that works. Works really well. And so this will return a number like 1, 2, 3, or 4, or 5, depending on how far it is away from the exit. So super easy to do. When we start this may be the one thing, if you're doing this as a whiteboard challenge, that they're actually looking for in that, and that you know this equation here. So that's how you do it. Pretty easy. Okay. So now that we have a kind of a move function, let's go back up to the top here, and we've got our move function written. And let's continue on. So now, if you look closely, the move up will return an object, and we can test for lots of things, okay? Which is can move, the distance, the direction, and the column value, all right? So for each move, we want to do this, and we want to say if move up dot can move. And see, now we have multiple return values out of this function, which I think is kind of cool. Equals true, because we're actually returning an object. So hopefully that is something that you learned today, that if you didn't know you could do that, you can do that. And so now we've got this next step array, and what I'm going to do is push into that array the whole object that we return, which is the move up object. Because it's got the distance, the direction, and the things that all the things that we want in there. Okay, so we've got that pushed in there, and that just means, hey, you know what? If you could move here, let's put that in the array, and then we're going to sort that. Remember our overview in a second. Okay, so we're going to do this 3 more times. Cut and paste these. All right, so as you can see here, we've got the move down function. It's just like the other one, except it has a different direction being passed in. So this move can process any direction and then return the appropriate object with the right properties in it. So we're testing to see if the move down can be true. And then if that's so, we push it into the array. So we got a couple more here. So we're going to move left. And so now we test the left move again, just for clarity. You notice here that we're passing in the directions of left, and then our object's being pushed back, and then we test to see if move left is true. And you can guess what the next one is move right. Same kind of deal here. And this is how we're testing between the move. And then after we've done all of our testing here, we can test to see if we have nowhere to go. And this is how you would test to see if there was nowhere to go. And so what we're doing is we just test the length of that array. So if it went through those 4 steps and nothing got pushed in, next step length would be equal to 0. And that way we could set the no exit equal to true, and then we could break out of there. And it would satisfy our condition down here in our while here. Okay? But if not, if that's not true, we need to sort the array, and we can sort the array like this. So we can sort it by doing next step.sort and just saying that I'm looking at the minimum distance. And what this will do is give us the minimum distance from smallest to tall. If you need to learn about array sorting, you can look at the documentation, but this is just a compare function that you have to write to sort arrays. And we're telling it what to sort on. And if you notice here, we can use a.minimum distance and b.minimum distance because this minimum distance is in the object that we push in here, move right. Okay? And we're telling it which column in that object to sort on. Kind of neat. Okay? And then finally, what we need to do is we need to pick the element that is closest to the exit, and this is how we'll do that. And we're going to write a switch statement again to do this. And so we're going to take, since we sorted it by the distance, we're going to take the very first one. Okay, so we're going to take the first element of all the ones that are pushed in here, and that's the position row, and we're going to grab the direction out of that object that was pushed in. And that's why we returned an object, because we needed multiple things from this return of the move function. And now we can test for each direction. So let's do that. And so like the first case is directions.up. And then if this direction is directions.up, then we're going to step count it, and then we're going to add 1 to our current row. It means that we're going up and we're going to break. So we can also test for the other methods. Now I'm going to show you that I put these in an order for a reason, okay? For a particular reason that I think is kind of crucial to the overall performance of this. I tested for up and down first. And what I'm my meaning of that is sometimes the direction or the minimum distance would come back equal. In that case, I could have two directions that have the same distance from the exit. And I made a decision to test up and down first. In other words, I want to move up and down the plane of the grid before I go left and right. And that allows me to create, so I know what I'm doing. Okay, and that allows me to perform these first in case I reach a left and right, that I run into a wall, then I have to go back and go up and back around. And so I choose to pick up and down first and then test left and right. And I think that is the best way to do it, because you always want to go up and up and up until you get to the correct target row and then move over with your step count. Okay. All right, and that's what all of these cases do. They do the same thing. It's testing on our directions, up, down, left, and right. And then if I'm going down, I'm taking one away from the current row. If I'm going left, I'm taking one away from the current column. And if I'm going right, I'm adding one to the current column. Okay, and that allows me to set up our move. All right. The next thing that I need to do is I'm going to mark the grid. And this is just simply our UI piece of this. And what I'm going to do is I'm going to mark the squares on the page, and I'm going to have a mark elements function. And so let's get that going. And our mark elements will return if the exit is reached. Okay. And let's tab this in here. I like this tabbed in a little bit. Maybe not. That's good. So let's write that marked elements function. And then we're ready to test this, and we're almost there. So thanks for hanging out with us. So I'm going to get this and cut and paste this in here. So let's move it down. Let's put it after our get element distance. And this, again, this is for the UI function of this. And what we're passing it is the target row, the target column, the previous row, the previous column, and the grid that we're working with. And just remember that those values that we're testing are in the grid, okay? So the first thing we need to do is set up a variable called element ID. And this is the element that we're going to mark eventually. And we set it equal to 0. And so the thing what I want to do is I want to test for if the grid and target row. And then I want to test for the target column. And I want to say if that equals a path. So remember this, how we did this. We're using our enum or our object here. Dot path. So let's get this right here. Okay, so if that equals path, let's do some stuff. And what I want to do is go ahead and set my, so what this means is if the target thing I'm trying to go to has already been walked on, then I don't want to go back there ever again. I'm going to mark that as a dead end. So I'm going to say grid, and I'm going to say previous row, and the previous column equals column values dot dead end. You're dead to me. That's what that means. I don't want to go back there again. All right, and then I can set my element ID equal to, and I'm going to use another temperate literal here. So the tick mark under the tilde sign, remember, and then we pass it in our formatting here. And from here, I'm going to say previous row. I'm going to look for the previous row, colon, And then I'm going to use my template literal function again, and I'm going to hit previous column. All right, and so that's setting up my element ID, and then as we did before, we just do a simple document dot get element by ID, and then we pass it our element ID, and then we do a set attribute. And we set the block value, selector or our attribute for the CSS that we made up, and we set it equal to dead end. And if you remember, our CSS says that's going to be orange. So our dead end will be orange, and we'll show that how this works here in a second. Okay, that's our first condition that we want to do in this mark elements. And so all we're doing is marking the UI now. So the next thing we can do is I want to set my element ID equal to the target value. So now if we need to mark the previous one, we did, but now we want to say my element ID, I want to set that equal to what my target value is. So I'm going to reset this up with my template literal, and I'm going to pass it target row. This is where we're trying to get to. Target column, target row, target column. So now we have the element ID that we're trying to get to, and we want to mark it. So same thing here, dot get element by ID, and then I'm going to pass it element ID, and then I'm going to set the attribute of block value, comma, and I'm going to give it a value of step. And this will make it blue. Cornflower blue. It's cool. And then I want to go ahead and set it in the grid. So the grid value is also going to be changed. So the target value, or the target row, excuse me, and the target column equals path. So meaning it used to be F, now it's going to be FP. But since we're doing enum, it's easier to understand kind of what we were doing. And that's it. And then finally, inside this mark move, we can also test for an exit inside this mark element. See if we're getting out of here. Okay. And so if save that, yeah. Okay, and we're going to say if, and then target row, and that's going to be equal to our exit row. If they're equal, and put the double at there, double and sign, target column equals testing for equality. If you set it a statement in here, it will break. So make sure you're using a test for equality and not an assignment. We want to return true, meaning that hey man, we're at the exit. Else we want to return false, which means hey, just keep on looking for that exit, don't give up. Okay, so that's that is our mark element function, and that's pretty cool. So let's look back where we were. So let's go back up here, and let's make sure we have everything ready. And I think, let me review this to make sure that we're ready to roll, that we're ready to exit and test this out and see if in fact we can mark a maze. Okay, so let's see if this is working here. And as you can see, I've got our application. I'm going to pull it over here. And we've got our grid selected here, so I'm going to hit solve. And look at that, it did in fact solve it. So it walked through and found the end, and it took out the 7, or told us that it took 7 steps. Now also it had this other scenario with a different grid that I put together, and the difference is here it has a an extra kind of obstacle in the way. And so we're just hit solve and see what happens. And if you walk through the code, you'll see that it from this position, this direction and this direction is the same distance. And so it walks up here first because we prioritize moving up and down versus left and right. And when it gets here, it only has a couple of choices, this way or that way. And when it exits back to a row that it has been before, it marks this as a dead end, and then it proceeds to walk it out. And that took 9 steps. It's actually 7 if you don't count the dead end, but if you do, it took 9. And so we solved that. So let's move on to the 0-hour code, and let's see how we would solve that one, and real quickly here. And so if we click over here, now we've got these different set of grids, and this is a different problem. We don't know the start or the exit. We just know that it has to figure out how to get on this predetermined path. So the code is kind of the same. We're going to write 2 new functions. I'm going to use a lot of pre-built code to show you kind of the difference between the 2 algorithms, because they're the kind of the same, but a little bit differences. We're not checking for distance. We're just checking to see if you can move left, up, and down, and right. All right, so let's check that out right now. Okay, so these are the grids, and so let's look at the code to do this. And to save us a little bit of time, I've kind of pushed the code in here so that we can look at what we're going to do. Now we're going to make a new function called solve_zh, and that's this one right here. We're also going to make a new function called move, because they do a couple of different things. So let's just walk through this code here. It's very similar to the solve maze code. So solve maze zh, or solve maze 0-hour, has the same variable setup. And what we're doing is first thing we need to do is we need to find the start column. And the thing that we know, which is very important when you're solving things, is what do I know? I know that the start is on row 0, and I know the exit is on the end at the last column. In fact, if I get to any column on the last row, I have found a successful exit. And so those are the 2 things that we know about this particular solve. And so what we need to do first is define the exit row, which is the grid length -1. And then we know the start row, we set that to 0. And then we find the start column, which is we look in this array of the grid and the array, and we find an index of isPath. Okay, now isPath is a function that we wrote down here. I'm going to show that to you. That just basically takes the element and returns the element if it's equal to false, okay, or it has an F value. So like if it does, it returns true. If it doesn't, it returns false. Very simple function that this does. And all that does is determine what our start column is, okay? So it tries to find the first index that has a path on it. We know there's only one that has it. There's not multiple entrances, there's only one. So the first one will work, all right? And then we set the current column, the start column, the current row to the start row. And in the case of our grid of the void type, which is our first one, that's going to be column or row 0, column 1, okay? And then we mark the start as the start of the path, just like we did before. We're using our same CSS set attribute to block value and setting that equal to step, which takes it to cornflower blue, okay? And we find it by this element ID, start, and column. Remember, we have a naming convention for each element on the grids, if you remember what we did. And so then we set up our do loop here, and we're doing the same thing. So we're testing each and every direction, up, down, left, and right. And we wrote a new move_zh function. Let me go through that real quick, and then we'll come back and show you the kind of the differences between the two. So move_zh takes in the current column, the current row, the current column, the grid, and the direction. And it's just like it was before, looking at the case of the directions using our enum. And it says it's setting the target row value, the target column value, the target column, and the target row based on which direction we're going for. So in the directions of up, we're adding 1 to the row. In the left, we're taking 1 from the column. And for right, we're adding 1 to the column. And for down, we're taking 1 away. Again, the same thing here. We're checking for out of bounds just like we did before to see if any of these values that we calculated are out of the bounds of the actual grid, okay? And then we return an object, which is the same, which is can move, minimum distance, direction, and direction or the column value that we're going to, okay? In the case of out of bounds, we're just going to set that equal to a wall. Now, one thing you'll notice difference about the moveZH function is that we don't care about the distance any longer. All of these will return a minimum distance of -1 because we no longer care. But I want to keep it consistent between each of the functions because there's probably a way to consolidate these functions to do the same thing without writing 2. But I wanted to separate them so that you could see the differences in what we're trying to do. And maybe that's a challenge where you could get this all in one move function, depending on what type of grid or what type of value you're going after. Anyway, so let's move on. So we get the value of the square we are trying to move to. So now that we have our target row and our target column, we get the value out of that. So remember, the values can be FT, and FP stands for if I've been there before, and FX is a dead end. And that's going to be real important here in a second. All right, so we know that we can't move back to the start. We must always go forward. That's true in mazes, and it's true in life. Always go forward, never look back. And then what we can do here is we look to see if the target value is open. That means that it has a value of F. If you look at our call values.open, those have our enum we set up here. We have 4 values: wall, open, path, or dead end. Okay, and we're looking for ones that are open. If that's F, if it's open, then we set the can move to true. The minimum distance will always be -1 in the case of moveZH. The direction is the direction, and the target value is what we're going to get. Okay, and that's what we're returning. So the target value is going to be F in this case. We also check to see if it's equal to a wall or a dead end. And that means that if it's a wall or a dead end, we cannot move in any of those directions. FX means dead end. Then if that doesn't true, we check to see if it's a path, which means that if you have to go backwards to a previous marked square, we need to mark the current square as a dead end. And that means that we can move backwards well. So that means that if we're going up, we could go backwards to a previously marked square, and the value of that coming back would be FP. So an open value would be F, and a previous value would be FP. And I want you to remember that because that's real important to our algorithm here. So in the case of the 0 hour, we'll always have at least a path that we can go backwards on, and always a path where we can move forward on, okay? In this case, all right? And then if we don't find any of those values, just to make sure that we always return something, we say we can't move anywhere. And that could be in the case of a not exit scenario, okay? So that's what that does. And so now let's look at the rest of our function here, which is move, our moveZH function, or our standard loop here in the middle, okay? So let's solve moveZH, excuse me. So let's start right here at the loop. And so now that we know what moveZH does, we can kind of walk through this. So the first thing we do is we test to see if it can move. We can move up, true. And if move up or move down or move left or move right returns true, then it pushes this into our next step array, okay? So in the case of the 0 hour functions, we're always going to get 2 values that we can move to. We can always move to the previous one, and we can always move to the up one. We always want to take the up one, the one that takes us closer to the exit. And so how we did that is we sort this by alphabetically here. And so we wrote a sort function. And all this does is it means that F would come first before FP. And then we could take the original or the first value in the next step array. So for the case of this one, we'll always have 2. And And then based on that, we then get the direction out of there and we move it. And then we go current row plus 1. If we're going up and down, we take 1 away. If we're going left, we go left. If we're going right, we go right. So that we can always test which direction we're going to, okay? I do believe that, I haven't tested this. I do believe the reason that I coded it the way I did is that I thought about making dead end in this mazes and it backtracking. This should work for that. You can probably make your own grids and test out that scenario, be easily modified if not. But I believe this would work in the scenario of a real maze where you have an exit and an end, but there could be a couple of dead end or false paths going out from the array. In the case of the 0-hour mazes, there was one and only one path. It just wasn't shown to you, so therefore you had to find your way through it. This code will find its way through it, and as it goes, it will mark all the elements just like we did before, and then that mark elements thing will return whether it reached the exit or not. And then while the exit is false or no exit is true, and if the exit is true, then it will actually say, write this success, it took how many steps to get there, okay? So that's the code in a really fast way to do it. I know this has been a long video, so I wanted to go through it real quick. So let's see if it in fact works and what the results should be. So in the case of grid day, and this is the actual grid that's in the 0-hour challenge, I can hit solve and look, it walked through the whole maze. Now what's important about this to understand is that the code itself doesn't know what the directions are, where it needs to go. It's testing each direction and it is solving it. So that itself is pretty cool. So if we look at the arc day, you can see here it went through and ran through all the arc puzzles, and on solar day it ran through all of those. Okay, so I think that's pretty cool. I hope you enjoyed this, and I hope you learned a lot about multi-dimensional arrays, maybe looping, or even template literals. I hope you got some kind of value out of this, and at least some comments in the comments if you need other questions or have something that you'd like to ask. If you'd like to get the code, visit the Coder Foundry GitHub page. We'd love for you to check it out and run it. And add this to your portfolio. Make it your own and add your portfolio. If you're a Destiny player, I would love to hear about your Destiny things. You can leave comments about there because I'm an avid Destiny player. But anyway, I hope this helps. Good luck and keep coding.